All right, in your warm-up, you are remembering the transformations we did the past couple days. Okay, if you had a function and you added or subtracted something on the very end of it, which way did it move? Either up or down. Okay, it went up if you were adding something. Whoop. There we go. If we are adding a value onto the end, that moved it up. If you were subtracting something off the end, that moved it down. All right, what about adding and subtracting inside my parentheses? What did that do? It moved it left or right. Which one would have moved it to the left? Which one of these moves it left? The bottom, because it's opposite. Yes, anything in your parentheses is going to be opposite. So this one will move it to the left, and a minus h actually moves it to the right. All right, multiplying the entire function by a value was the next one we worked with. If we multiplied the entire function by an a value that was bigger than 1, that was considered a vertical stretch. Vertical stretch by that a value, whatever it is. Okay, what if it was in between 0 and 1? It was a vertical shrink. Okay. A shrink and a compression are the same thing. So Algebra 1 uses the word compress or compression a lot. Algebra 2, we use shrink. It is the same thing. Okay. Speaking of Algebra 1, look at what I'm doing in Algebra 1 this week. I'm doing transformations of lines and absolute values. What are we doing? Transformations of lines and absolute values. Okay. So if some of this seems familiar, that's on purpose. It should seem familiar. In Algebra 1, it was very graph focused, where like you physically move the graph. You'll notice in Algebra 2, looking at your paper, do you see any graphs? No. So we are very function focused. Okay, how do we show the transformation in the function, not so much on the graph anymore? Okay, so it should seem familiar, but Algebra 2, we do take it that level up. All right. Okay. So doing an example of some of the stuff we just worked on in our warm-up, we have f of x equals 2x plus 1. All right, is that a line or is that an absolute value? That's my line, okay? Write a function g whose graph is a translation 3 units down of the graph of f. So this line has gone down 3 units, okay? I don't have a graph, I'm writing the function. So we take my original function and we do what to it to show down 3? Down 3, we're going to minus 3 on the outside. Whatever the function is, it is minus 3. Okay? That is the case for whatever function you're working with. A line, an absolute value, a square root, a rational function, a logarithm. It's a fun word. Okay? Transformations are the same no matter what the function is. Okay? So to move down, I'm always going to subtract off the end. Okay? What was the function I was subtracting from? F of x is 2x plus 1 minus 3. Is that my final answer? No, because I can do the 1 minus 3 on the end. So I can combine like terms and simplify this function to give us our final g function, which will be 2x minus 2. Okay? Does our math make sense? My y-intercept was at positive 1, and now my intercept is at negative 2. Did it move down 3? Yes, it makes sense. All right, my next one wants me to write a function whose graph is a translation 2 units to the left of my original function f. Okay, so how do I show 2 units to the left within my function? We have to do x plus 2 inside of my parentheses. Okay. So it's no longer f of x, now it's f of x plus 2, meaning any x that was there to begin with is now an x plus 2. Okay, so it's not going to be 2 times x plus 1. It's going to be 2 times x plus 2 plus 1. All right, which ends up being 2x plus 4 plus 1. So I distribute the 2 through my parentheses, and then we add my 4 and my 1 together to get our final g function is 2x plus 5. Like that. Okay. Questions about up, down, left, right when it comes to a line? Because after this one, we're going to be very focused on absolute values. Sweet. Okay. Yes. Oh, it does say h, doesn't it? Yes. Good. Might seem silly, but it does matter. It shows it's different from the one before. Also, on your big ideas assignment tomorrow, if you had what I had, g equals 2x plus 5, it would have told me I was wrong. So thank you for bringing that up. I would have had to say h equals 2x plus 5. Big ideas is very picky. We'll figure that out tomorrow. They tell you to use something, use it. All right, we're going into new stuff. We have not done reflections yet. We can reflect over 2 different things. Reflect over the x, and we can reflect over the y. Okay? Reflecting over the x-axis, okay, means we are moving which direction? Up and down. So does that change my x values, or does that change my y values? It changes my y values, okay? Whatever was positive is now negative. Whatever was negative is now positive. Do we agree with this? Okay? So the negative is affecting our output, which is our entire function. So your negative goes on the outside. There you go. Okay, all of your outputs get multiplied by -1. Okay, so my other one, reflecting across the y-axis, what's moving? How are we moving? Now we're moving left to right. My x's are now changing from positive to negative or negative to positive. So where's my negative going to be in my function? Inside my parentheses with my x. So here, all of my inputs are being multiplied by -1. All right, this one is outputs. Oh, can't spell. Outputs multiplied by -1. This one is inputs are multiplied by -1. Like that. Okay. Now let's see what that does to an absolute value. Because what are absolute values? When you plug a number into those bars, what comes out? Always the positive version of it, right? So let's see what a negative would do if I put that inside my bars, right? That's going to be something special. So let's start with, we have our original function. This time is absolute value of x plus 3 plus 1. The first thing is a reflection across the x-axis. Okay, so is my negative going outside or inside? It's going outside. So we're doing the negative of our function. I'm going to zoom in so y'all can see a little bit better. Okay. Our function was the absolute value of x plus 3 and then plus 1. Okay. The entire thing is getting multiplied by a negative. Okay. Everything gets multiplied by a negative. Okay. Is that negative going to go inside my bars? No, it is not, but it will go in front and behind my bars. Okay, everything gets multiplied. So we're going to distribute it in front of the bars and after the bars. It goes both places. That's how you distribute your negative. Okay, that is going to leave me with our g function of negative absolute value x plus 3 and then minus 1. So my vertex was 1 above. Now it's going to be 1 below. My math makes sense. Okay. It was facing up. Now it's facing down. Our math makes sense. Okay. But it did not move left or right. So the x plus 3 should still be x plus 3. Good. Ready for the y-axis? Flip it around there. Now, if your vertex is sitting on the y-axis, that's nice because it's the exact same thing, right? If you flip it around. Okay. But if I have been moved, because notice we're not starting at the parent function anymore. If we've moved somewhere else, there is going to be a change that happens to our function. Okay. So here, reflecting across the y-axis means that my negative is now inside with my x. Okay, so the x that was there is now a negative x. Like that. Okay. Now, if you were in Algebra 2 general class, I would stop right here because you've shown me that, yes, you understand the transformation of reflecting across the y means changing my x to a negative. You've shown me you understand that transformation is in function form, okay? But you're Algebra 2 honors, right? So let's do some more, okay? This answer, perfectly acceptable. Tomorrow on Big Ideas, they'll love it, okay? You can take it another step further because there is another answer. Okay? Let's do it. You can factor out an absolute value of -1. Okay? Because mathematicians don't like negatives inside absolute values if we don't have to have them in there. So technically, I could factor out a -1. It was absolute value, so you're factoring out an absolute value of -1 to both pieces. Changes my negative x to a positive x, changes my positive 3 to a -3. Okay? Now, what is the absolute value of -1? Just 1. So do I even need this now? No. So I can say g of x equals the absolute value of x minus 3 plus 1. Think about that image in your head. We started off with, where's my blue? What was it, -3, +1? That's where our first function started. If I'm reflecting across the y-axis, I said my x is changed by negative, right? So we're not at -3 anymore. Where's my new one going to be at? I should be at +3. And is that shown in my g of x function? Yes. So now I have +3, 1. Okay. So this is mathematically the simplified correct answer. Okay, and your honors kids, you should be able to understand that. Okay, reflecting across the y means you're changing the x vertex from a positive to a negative. So your original was positive 3. Look at your final answer. It's negative 3. That shows the x got reflected across the y-axis. Okay. Again, big ideas. We'll take either one of these. Okay. I will accept both of those. They are technically the same thing. We good? Okay. All right, let's talk about stretches and shrinks. Okay, we had done vertical already, but we haven't done horizontal yet. All right, so let's talk about what I know. I know vertical stretch and shrink. Okay, we did this already. It was in my warm-up. A vertical stretch and shrink was when you multiplied an entire function by a value of a. Okay. So we're going to start with what we know, and then we can compare it and do something new with it. Okay. Okay, so we talked about in our warm-up that if that a value was bigger than 1, that ended up being which one, a stretch or a shrink? Ended up being a stretch. I'm going to say vertical stretch. And if it was in between 0 and 1, it was a vertical shrink or compression, same, different word, same meaning. Okay, we did that yesterday. Okay, this pulls my graph up and down. This shrinks my graph from the top and bottom. So either pulling it apart or squishing it together. Stretching it apart or shrinking it together. Oh, look at that. Okay, because you're multiplying the y values by a bigger number, so your y's get bigger, they stretch out. Multiply your y's by a number smaller than 1, they get closer, they shrink. Okay, now I said I will say what 1,000 times? Inside opposite, inside opposite, inside opposite. Okay, so instead of multiplying the outside by a for horizontal, we're going to multiply the inside. Whoops, helps to have an X. The inside by a. Okay, and this is a factor of 1 over a. So with stretches and shrinks, we just say, oh, factor of 2, factor of 10, whatever, right? When we have stuff on the inside, we say factor of 1 over a because it's the opposite. It's the reciprocal. So now if our value is bigger than 1, if our a value is bigger than 1, we're inside, so now we're horizontal, and we're not a stretch anymore. Now it's a shrink. And it's by 1 over whatever that a value is. So it's a horizontal shrink by 1 over a. So if we had like, I don't know, give me a number. 10. If you had this, that's a horizontal shrink by a factor of 1 over 10. Okay, it's opposite. All right. All right, what if we're in between 0 and 1? It's inside, it's horizontal, and it's not a shrink anymore. Now it's a stretch. Okay, and you would do the reciprocal. So let me change this. If this was, give me a fraction. Was it 1 over 4? Okay. So that's a horizontal stretch by a factor of 4. Because you flip it. You would say by, okay, 1/4. The factor is 1 over a. Your a, oh, that should be an x. Y'all gotta tell me when I do something silly like that. So you would say that's a horizontal stretch by a factor of 4. Okay, because isn't that the reciprocal of 1/4? Okay, let's do more with this. The more we do, the better we get. All right, but again, you know vertical, right? You know vertical, and if you know vertical, you know horizontal. Okay, if you have a shrink horizontally, you're being pushed from the sides. If you're getting pushed from the sides, would that make my V more narrow? So is that visually the same thing as a vertical stretch? Yes, that's why those two kind of match up. Okay, a horizontal stretch would pull something out from the sides. Wouldn't that make my V wider, like a vertical shrink? So that's why those two get matched up. Okay. All right, let's do it with absolute values. Okay, we have the absolute value of x minus 3 minus 5. My first one wants me to write a horizontal shrink of f by a factor of 1/3. Okay, so if we're doing a shrink of 1/3, what is our a value? Thank you. 1/3 is the same thing as 1 over a. So a is 3. There you go. So a horizontal shrink means we are multiplying my x by 3. That is a horizontal shrink by a factor of 1/3. Okay, so let's put it into our equation. So we're not doing x minus 3 anymore. What is it now? 3x minus 3. Did my negative 5 change? No, still there. There we go. That shows the horizontal shrink. Okay. Ooh, bonus fact. Ready? Because you're honors. Let's look at this. Could I take a 3 out of my absolute value bars? Yes, just watch this. Just watch this. If I did this, that's not a horizontal shrink anymore. What is it instead? Now it's a vertical stretch. Didn't we just say that that was the same thing? Yeah. But my answer is what's in the box because it wanted a horizontal shrink. It didn't ask me for a vertical stretch. Does that make sense? So yes, they're the same thing, but it didn't ask me for this. It asked me for the horizontal shrink. All right? What, Emma? Vertical stretch. Visually, it's the same thing. Yes. Yeah, so it'll be specific on which one it wants you to do. Yeah. Yes. So like I said, these equations were technically the same thing, but it wanted the horizontal shrink, not the vertical stretch. Yeah, so just it's more detailed now that you're in Algebra 2 honors. Woohoo. Are you ready for my next one? Yeah, you are. Here we go. Vertical stretch by a factor of 2. And yes, I know there's a dot F right there, and I don't know why. It means nothing. It shouldn't be there. I'm sorry. I don't know what happened when I was typing. So don't let it confuse you. All right, a vertical stretch by a factor of 2 means we do what to my function? Multiply the entire thing by 2. Do I have to do any flippage or anything weird like that? No, because it's vertical, not horizontal. Okay, we are vertical. Do you remember with the negative when we did the reflection that was negative on the outside and we had to distribute that? Remember that action? We're doing the same thing, but now it's with the 2. Okay, so this is going to be 2 times the absolute value of, what was it? X. What is it? Minus 3 minus 5. Bless you. Bless you. All right, so we're going to distribute that 2. Does this become 2x minus 6 minus 10? Does it become 2x minus 6 minus 10? Say no. No, it does not, because it does not go in the bars. It goes in front of your bars. It goes behind your bars. It does not go inside your bars. Okay? So instead, what is this? I heard it 2 times the absolute value, x minus 3, and then minus 10. It goes in front and it goes behind. It does not go in the bars. And then that's our final answer. There's nothing else that can be done. Yep, we'll leave it just like that. All right, a lot happened on the front. Do you have any questions? That was a lot of information I just dumped on you. We're okay? Because we're going to use it now on a couple of problems on the back. Okay. All right, example 4, we're going to examine a table and tell me what transformation happened. So it's showing me 2 absolute value functions, f and g. Describe the transformation from f to g. So my x values are -3, -2, -1, 0. My f is 10, 6, 2, 6. My g is 5, 3, 1, 3. So what relationship can you observe on this table? What relationship do you see? What's happening? All right, g of x, she's saying g of x is half of f of x?
Shrink.
Yes? What kind of a shrink? Vertical shrink, yeah. Can we all agree that so if these are half of those, what did f of x get multiplied by? They got multiplied by 1/2. Okay? Okay, so my outputs, so we noticed outputs were being multiplied by 1/2. Okay, so in function form, to get to my g's, I had to do 1/2 of my f's. Does that make sense? Where that just came from? To get to g, I had to take 1/2 of f. So, Daniel said it, what is my transformation? Vertical shrink by 1/2. Okay, so we observed outputs being multiplied 1/2. I put that in function expression, which showed us our vertical shrink. So I'm kind of like showing you our thought process here. That's how we came to the conclusion, vertical shrink by 1/2.
How do we know that it's vertical over horizontal?
Because my y's changed, not my x's. The table would definitely look different if it was a horizontal something. All right, number 5, we're going to graph kind of like what we did yesterday or the day before, but we're not starting from the parent function anymore. Okay, here we're starting first with the absolute value of x plus 2. Okay, so describe the transformation from that being represented by g of x equals -f of x minus 1. Then we're going to graph each function. Okay, so first off, just looking at this transformation function right here, what does that negative mean? Yes. And we're not going to say flip anymore. We're going to say reflect. Again, big ideas is picky. You will not see flip as an option. And then how about that -1? To the right one. And again, we're not coming from the origin. So when I graph this, I have to come from the first function that gave me. Okay. So where did my absolute value start? Not on 0, 0. It started -2, right? This showed that it's already been shifted to the left 2 units. My slope didn't change, and we're still opening up. It's a positive one. So we're going to go up 1 over 1 on both sides. Make sure you label this as f to show the first function, the first absolute value graph. But we're doing it from this one. Nope, it's still just right one. We're not moving from the parent. We're moving from this. So from this blue, now I'm going to move to the right one. So from here, I'm moving to the right one. And reflection across the x, that means my y values changed. So we're going to go down now. Like this. So this one's different. You're going from that x plus 2. Okay. The x minus 1 is in parentheses. That's showing a transformation. That's not showing you a new point. You see the difference? Okay.
So if the g of x,
Yes.
moves left 1, right? I thought if it was in parentheses, it's
Opposite. Yeah. So -1 means to the right. So we went this way.
All right. I just saw a graph of -1.
Yeah, because it came from this
okay,
too. Yeah.
The first one was the path.
Correct.
Oh.
Yep. Yeah, we're coming from this blue, which started at -2. If you go to the right one from -2, now you're at -1. Yes. Okay. All right. We're going to do a combination of transformations, but now we're going to do it in function form. All right. Let the graph of G be a vertical shrink by a factor of 0.25, followed by a translation 3 units up. Okay. So here, it lists multiple transformations happening, right? It lists multiple transformations going on, okay? You have to do it in the order that they tell you, okay? This told you a vertical shrink happened, and then it went up 3, okay? That would look very different from up 3 and then a vertical shrink, okay? So pay attention to how it's worded. So we're going to do a vertical shrink by 0.25 first. How do I do that to my function? We'll call it h. So the first thing I'm going to do is multiply our function by 0.25. Okay? Okay? And then whatever that equals, so we're not going to do it yet. After I figure out what that is, to get to g, the last thing I'm going to do is take my previous answer, and then what does it say? Up 3, and then we're going to add 3 to it. Okay? So we'll multiply by 0.25 first, and then I'm going to add 3. Okay? You ready to actually do it? Yes? What's up, Emma? Okay. Okay. All right, so my first step, make it rain. So what is my function, by the way? It's just x. So to do 0.25 times my function is just 0.25x. That's nice. Now I get to do what to that function? This is technically my h. Now I get to do what? I get to just add 3 on the end. So 0.25x plus 3. The end. Nothing else to do. This is my g. Okay. If I would have done them in the wrong order, I would have had x plus 3 and then multiply all of that by 0.25. So I wouldn't have a plus 3 on the end anymore. I would have had whatever 3 times 0.25 is. See how that's different? Not the right answer. So do it in the right order. All right, here we go. And if there was something to combine, like if I had an x plus 1, I would have to combine that with the plus 3. Does that make sense? We did it earlier. So it won't always be this nice and straightforward. There might be more stuff to do. You'll get that tomorrow on Big Ideas. Here we go. Last one, modeling real life. You are designing a computer game. Okay. Your revenue in dollars for X downloads is given by f of X equals 2X. And your profit is $50 less than 90% of the revenue. Okay. What is your profit for 100 downloads? Okay. So let's put into words what they're trying to ask me. Okay. They're asking about a profit, right? They're asking about a profit. How do we make a profit? Tell me in words. Money. Where does the profit come from? What does it say in the word problem? Put it away. There it is. It is $50 less than 90% of your revenue. Okay, it told me that in words. So I need to know what 90% of my revenue is, and then I'm going to take away $50. So profit is going to be 90% of our revenue, and then take away $50. Okay. So I've kind of put it into words. Now let's put it into a function. What's up? Hold on. Okay. So to get our P of X, our profit, am I going to use 90%? What do I use in equations? What's 90% as a decimal? 0.9. There you go. 90% of my revenue. And where did revenue come from? How do we find revenue? There it is, 2x. Your revenue is given by f of x equals 2x. So to find revenue, we use 2x. And then minus 50. Like that. Okay. Is there any simplifying I can do with this equation? Yeah. Technically, I could do something. I could do 0.90 times 2x. And what does that give me? 1.8x minus 50. Okay. So there is my profit equation. But now how am I going to use that to answer my question? What is it asking me? What's your profit for 100 downloads? So what are you going to do? Like 100. Do you have a question for me? Yes, thank you. The x is going to be 100. The x is going to be 100. So we're going to plug in 100. You do it. It's the only time you have to actually use a calculator today. You do this. All right, so what do we get? What do we get? We all got 130? Yes? That is definitely what you should be getting. We should be getting 130. Word problems get word answers, right? So all this green is nice, but that's just your work, showing your work for the answer. Your profit after 100 downloads is $130. Yeah? We okay? Okay, get used to word problems. You're going to have them every single time. Okay, because you might hate them now, but if we do them over and over and over and over again, you're not going to hate them anymore. We're going to have more understanding how to break these things down. All right? Yes, good job.